Dear students, today we are going to learn about the periodic table of elements, that is introduction part. It is useful to intermediate students, 10th class students and entrance going DSC and other entrances going students also very useful. In the introduction part, how the elements were classified, what are the various theories involved in this classification can be known. We are using now modern periodic table. So, in the modern periodic table, how the modern periodic table now which we are using is happened, what is the previous history of this attaining this table can be known by this introduction. So, the earliest classification of elements, when the elements are very less 10 or 11 like that, the elements were classified into metals and non-metals. Classification is very important, because if less elements are very less, students are less. For example, let us take students in the class. If they are 5 or 6, then teacher can know all the properties of individual students, all the profile of the individual students. What is his father, what is his mother, and what type of his education background of his brothers and etc. And what is the IQ abilities, everything he can remember, the teacher accordingly he can teach. But if the students are number is increased, then it is difficult to learn or difficult to know the properties of students or profiles of students. So, the classification he will do. What type of classification he will do? He will take either the IQ ability or gender basis also. IQ ability, intelligent students one section, and below average students another section, below average students in another section. Accordingly, he can teach to the students. Or sometimes if more students are there on gender basis also, they will be classified. So, women's college or women's section and men's section, boys section or girls section, like that you can classify. Similar way, as previous days, the elements in olden days, the elements are very less. So, they were classified, the elements were classified in simple way, metals and non-metals. What are metals? Metals have metallic luster, metallic shining, and they are good conductors of heat and electricity. Whereas non-metals, they have no shining, they are bad conductors of heat and electricity. So, such type of classification was done in the olden days. But at that time itself, some elements were discovered, like silicon, germanium, like that. They behave, they exhibit both metallic and non-metallic natures. So, this classification, because if for example, you take silicon, it has a shining like it has no shining like non-metal, it is a good conductor of electricity. So, it has both metallic and non-metallic natures. So, such that classification, this classification of metals and non-metals, that was failed to classify the elements as the number of elements discovered or increased. So, the first reasonable, later on the first reasonable classification of elements was done by Dobereiner. It is called Dobereiner law of triads. Dobereiner thought the elements were in the order of, kept in the order of 3 elements in the increasing order. You can, if you put the atomic weights of the first and third elements, take average, that average atomic weight will be the equal to the middle element atomic weight. That is, you can say, for example, lithium 7, potassium 39, the average is 7 plus 39 by 2 is equal to 23. It is equal to sodium, that is the atomic weight of sodium. So, lithium, sodium, potassium has similar properties when they are kept in the increasing order of their atomic weights. They follow what type of principle? The atomic weight of first element and the third element. If you take the average, that atomic weight is equal to the atomic weight of middle element sodium. For example, you take some more triads. These triads are called actually Dobereiner triads. These triads are called Dobereiner triads. For example, you say lithium 7, sodium 23, potassium 39. The average 7 plus 39 by 2 is equal to 23. That is equal to. So, this is the first Dobereiner triad. Another Dobereiner triad is calcium, strontium, barium. The atomic weight of calcium is 40, barium is 137. If you take the average, that is equal to 88.5. The atomic weight of strontium is 87.6. That means it is approximately equal to the atomic weight of the middle element. So, this triad means 3 elements, set of 3 elements is called triad. This triad is also called Dobereiner triad. So, another Dobereiner triad is chlorine, bromine, iodine. Chlorine atomic weight is 35.5, iodine atomic weight is 127. If you take the average, the atomic weight is equal to 80, that is bromine. It is approximately equal to the average 81.25. So, these 3 triads follow his law, Dobereiner law of triads, but the other elements are not following this principle, this law. So, it was failed. Afterwards, Newland's law of octaves was proposed. Newlands is a scientist name. He proposed a law of octaves. He was very fond of music. He thought that sari gama pada ni sa, sari gama pada ni 7 letters. After words, the 8th letter comes sa. So, it is equal to the first letter. So, he thought elements also follow that type of some principle. So, he proposed octaves, law of octaves. Sa re ga ma pada ni sa, sa re ga ma pada ni. Again sa comes. Similarly, the elements are at that time some 20-21 elements are there discovered. So, they were kept in the increasing order of their atomic weights: hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen. These are 7 elements. At that time, the elements are there. Gas are not there. The element. Afterwards, the fluorine is a gas, hydrogen is a gas. Similar properties. Fluorine and lithium and sodium. This is first element. This is 8th element. Every 8th element is has similar properties to its first element. Magnesium is the 8th element. If magnesium is the 8th element, the beryllium is the first element. So, both are having same properties. Aluminum is the 8th element. Aluminum, suppose it is 8th, 7th, 6th, 5th, 4th, 3rd, 2nd and 1st. So, the first element and 8th element have similar properties. Carbon, silicon, nitrogen, phosphorus, arsenic, sulfur. So, every 8th element has, when they are arranged in the increasing order of their atomic weights, every 8th element resembles to the first one in properties. as in music. So, he proposed this law, but after 20 the atomic weight, that is calcium, the other elements were not followed this law. So, it was failed. This law was is good up to calcium only. It is failed completely after discovery of inert gases. Inert gases were discovered, they were not came in this Sarigama Padanisa rule, they are not following. So, it was failed up to calcium only, 20 atomic number, that is at that time atomic number is not there, up to calcium only. Afterwards, our hero Mendeleev proposed a periodic law. He is a first successful classification of elements was done by the Mendeleev. By proposing a periodic law in the form of a law, he proposed that periodic law. According to him, physical and chemical properties of elements are a periodic functions of their atomic weights. If you take if you consider the physical properties and chemical properties of elements, and you write the elements in the increasing order, similar physical and chemical properties elements came in regular intervals. In regular intervals, that was observed by Mendeleev. So, it was proposed in the form of a law, that is called Mendeleev periodic law. Physical and chemical properties of elements are periodic functions of their atomic weights. This is the Mendeleev periodic law. If one can ask in a entrance, Mendeleev periodic law depends on A, atomic number, B, atomic volume, C, atomic weight, D, mass number. So, atomic weights, that is important. Mass number is a round figure, whereas atomic weight is the correct atomic weight. So, atomic weight is the correct answer. On the basis of this law, elements discovered at that time were arranged in the increasing order of their atomic weights. Atomic weights, like if you say take suppose a jamun or apples. Suppose 3 baskets of apples were came. How the farmer classify the apples? So, you take 3 or 4 vacant baskets, and he will see each basket, its weight or its size, its shape, its color, and in accordingly he separate all the apples which was collected into they were collected into according to their sizes. He will separate in some groups, 4 groups or 5 groups. He will fix the rates. The bigger size group has some 10 rupees, and the medium size 7 rupees, smaller one 5 rupees, very smaller one 3 rupees. Like that he will fix the rates. That means when the elements are more, if you see the size or color or anything to separate the apples, like that he considered the atomic weight. He kept the elements in the increasing order of their atomic weight, and when the properties are similar, they come into the same group. He kept in the same group, and he framed in the form of a table. That table is called Mendeleev periodic table. Mendeleev periodic table is a word periodic table, that is, it is dependent. Mendeleev periodic table is dependent on atomic weights. What are the salient features of their Mendeleev periodic table? On the basis of this law, he arranged the elements in the form of a table called Mendeleev periodic table. This table consists 8 groups, vertical columns. Vertical columns are called groups, horizontal rows are called periods. Here in Mendeleev periodic table, how many groups are there? 8 groups are there. At that time, 0 group inert gases are not given in that form of a group. So, the other elements were given groups, 8 groups and 7 periods. 8 groups, 8 vertical columns and 7 horizontal rows elements were kept according to by considering according to increasing order of atomic weights. The elements were arranged and in the form of a table which consists 8 groups and 7 periods. This table is called Mendeleev period table. It is not a modern period table, it is a Mendeleev period table. Here 0 group is later added, but at that time Mendeleev only 8 groups are there and 7 periods are there. Each group are subdivided into subgroups. For example, first group you take first A, first B, second A, second B, third A, third B. Like that, in that group of elements also subdivided into subgroups. Each group is divided into A, B subgroups. There are 3 elements in 8th group. A group of 3 elements separately kept in the 8th group, which are called transition triads. If there are 3 elements sets are arranged in 8th group, they are called transition triad. Means 3 elements, transition triad. In the previous time you have seen Dobereiner triad. Here these triads are transition triads. Dobereiner triad follows the principle, the average atomic weight of first and third elements is equal to the atomic weight of middle element. Here they are these transition triads are of iron, cobalt, nickel, ruthenium, rhodium, palladium, osmium, iridium, platinum. So, what are the main defects in the defects? What are the defects and what are the advantages of this table? Defects of